Go.
Hello.
Hello, Mr. Area, right?
Yes.
Okay, so today we talk about KNN. KNN. Okay, K, a number. N, nearest neighbors. Can you put it down? It's quite dangerous. Nearest neighbors. Nearest neighbors.
Oh.
Neighbors. Okay? So what does it mean? What does it mean? KNN. So it's like it's a machine learning. You know, have you heard the word machine learning? Computer can learn, right? Yeah, predict, make a prediction. We ask computer to make prediction, to learn from data. Learn from data. Yeah, data. Okay? Or sometimes we call it data training set. Yeah. So what does it mean? So I give you an example. So we have a few, we know already existing data, and then if you're given a new input, what would be the output? If this data, if this fx, this look, okay, the function takes the input x. Can you put it down, please? It's quite dangerous. Yeah, and then it generates the output. Yeah, output, right? Output. But we don't know what's fx. It's a very complex model, for example, right? Yeah.
Yeah.
For example, like it's very very complex. For example, the computer predict the weather. What's the weather going to be like tomorrow? Right? It depends on lots of factors. Right? The temperature, the seasons, right? The locations, right? Yeah, and the humidity, yeah, humidity, yeah. And what's the weather going to be like? So we don't know the model, or we can't express this model in mathematics, like simple mathematical equation, right? But we know already from the history data, yeah, we know already it happens before, right? Right. So for example, we have this input, right? So maybe like input, the temperature, yeah, and what else? What else? Temperature, the humidity, yeah. Is it, how do you spell this word? Yeah.
I don't know what you mean.
You know humidity, the how wet the air, right? Something like that. Yeah. Humidity and what? Location. Yeah. 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 Location. Location. Right? So we have observed this kind of data in the past, right? So something like 25 degree, maybe 30%, yeah, and the weather will be sunny, yeah. For example, yeah, sunny, and then something like that will be raining, right? Raining. Okay. So these data we collected. We already have this data, right? And we want to build a very complex model, yeah, to given tomorrow. So x could be the input, right? So we know the location, temperature, humidity for now, and we want to predict the weather tomorrow, right? And it will be very complex. And then we ask computer to predict. Let's make a prediction based on what we know so far. Let's call machine learning, right? So the data, the PC, the computer will work out, right? Work out the likelihood of the different kind of weather based on this data. Okay, this is kind of machine learning. Make sense?
Yeah.
Okay, so another example. Could be simple. Okay, so I have two shape on the board, on the space. Triangle, square, triangle, square, square.
There are only triangles and squares.
Yeah, there are two triangles, square.
There's just only.
Okay. So, can you tell me? So I have a point here. So is it triangle or is it square? Well,
Circle.
no. I mean, if I want to draw a shape here, right? This is the known input for the computer, right? Like the weather thingy, right? We have known that at these points it will be triangle or square. And now there's a new input. The computer, you ask computer to predict what's the shape here. More likely, you know, what's likely to be a shape here? Triangle or square?
Square.
Square. Well done. Why is it square? Why is it square? Yeah, it's square. Why? Likelihood, right? Yeah, it's likelihood. More likely. Likelihood. Okay. So machine learning it wants to solve a prediction problem. It could have this you know, it's not like 100% accurate. It's more like optimum, like heuristic, yeah. So we want to predict here, and then the computer will say it's square. So why you say it's a square? Come on, it's yeah. The algorithm is square. Why? Unless you can say it's a triangle and you can base another story. Just explain your thoughts. Why is it square here?
I'm not sure.
Now, your instinct? Why is it square here?
I just guessed.
And why? Based on what? Why is it square? A good guess. Yeah. Why is it square? Guess. How do you guess it's a square? Or you just random guess?
Just a random guess.
Likelihood. You could be look. I'm at this point. Yeah. I'm at this point. So if k equals 3, I want to pick the 3 nearest neighbors. So at this point, distance. What are the 3 shortest distance to this point? If I put a triangle here, yeah. What's the 3 shortest distance?
Triangle, square.
Yeah. So these are 3 shortest distance. K equals 3. Yeah. Normally k equals 3. Yeah. It could be if there are only 2 possibilities, triangle and square, and we want to pick a k which is odd. So there's no even vote. Yeah, because there are 2 possibilities, and if I have 3 votes, what does it mean? Always one wins, right? Yeah, 2 triangles, 1 square, or 2 squares, 1 triangle, right? Yeah, we don't have this even votes, right? If you put a k equals 4, what could be the even vote? 2 square, 2 triangle. You can't pick, right? So k equals 3. So we pick the 3 nearest. 1 triangle, 2 squares. So we will vote for what? Square. Easy. Yeah. That's how you guess. You make a guess based on these k. Okay, easy. Yeah. This is machine learning. The simplest machine learning algorithm, right? You ask computer to make a guess. Based on what? Based on the existing data. We know this existing data. Yeah? Existing data. And we also call it data set. Training set, data set, training set, training data set. Yeah, because these data are used to train the computer, right?
What if you did?
Sorry.
Okay, will it be on the grid or something?
On the grid. What do you mean on the grid?
Because what if you don't know which one is closer?
Okay, how do you calculate certain distance, right?
Yeah.
On the grid, yeah, the distance, certain distance. You know the distance. You could be there could be two kinds of distance. The distance, yeah. Look, what kind of distance can you get?
What if you have like 1 square and 1 triangle close, yeah, and
X, Y, yeah.
what if you had this point and the closest is 1 square and 1 triangle and there is another one
Called what? Circle.
and there's another one that is also triangle and square, but they're the same length from that point.
Where down? Okay, so that's a very good choice. Yeah, you have 3 votes, but one of them is triangle, one of them is square, and one of them there are 2, right? In this case, you just pick one of them. It's just 50-50. Or you could increase the k, right, to 5. Yeah, instead of picking 3, you're picking 5 to see more. Yeah, to get more, right? Got it? Do you understand what I'm saying? Yeah.
Yeah.
Okay, very clever, very good. Yeah, I didn't think of that before. Yeah, but yeah, you make a choice. That's a very special corner case. Okay, so we talk about distance. There are 2 kinds of distance you can maybe look. This is A point, right? X1, Y1, right? X1, Y1, okay? Yeah? So this is X1. This bit, yeah? Here is Y1, okay? And another point here. Okay, so here, X2. Here, Y2, okay? Right? Got it?
Yeah.
What's the distance? Distance, look, distance could be X1 minus X2 squared. Yeah? Plus Y1 minus Y2 squared. And then square root. That's one distance. Right? Because we're only interested this distance, yeah? This distance. What's the distance? It's equals to what? So this bit is X2 minus X1. This bit. This bit is what? Y2 minus Y1. Right? So we know this. AB. What's the distance? Look, we talk about this triangle thingy. Right triangle. This is A, this is B. What's this?
C.
No, it's no C. What's C? C, what's C? C square equals what? Remember? A square.
And these.
Yeah, got it? And it's all positive. Yeah? Got it? That's where it comes from. Yeah? And there's another distance called Manhattan distance, which is just this x1 minus x2 plus y1 minus y2. Look, what's this? Look at this. Absolute value, right? Absolute value. So look, if this is 3, this is 4. If this 3, this is 4. The distance, the Manhattan distance would be 3 plus 4 equals 7. But the first one, I don't know what's the distance is called. Yeah, this one would be 3 square plus 4 square. Square root equals 5. Okay, so there are two distances. You can choose any of them. Yeah, remember we picked the shortest distance on the previous, right? Yeah, got it? So what are we trying to solve here? If this problem is quite complex and we don't have a deterministic, deterministic, what's deterministic? We don't have a deterministic way to predict it. So for example, this fx, the model could be quite complex. You have the input. Yeah, we want to get the output. So what's the output? What's the output? Right? Fx, right? You have a lot of training data, and we want to know what's the output. Okay? So let's do this KNN. So what's KNN? So we find the k nearest neighbors to the input, and then we get the average. We can do the average of it, right? Or we pick a median, or we put a weighted average, right? So there are lots of ways. But first of all is we need to find the k nearest neighbors to the input, right? Okay? And then we can do the average of it. Yeah? Or we do the vote. If you want to labeling, right? If there are two choices, yeah? Triangle or square, we count the votes. Yeah? Whoever wins, whoever got the major votes wins, right? In the previous case, there are two votes of the squares. So we tend to vote for that point as a square, right? Yeah? And if it's a value, right? If it's a value, it could be chosen as a value. For example, like, look, let's do this. X, Y. If we do a graph, y equals x squared, right? Yeah? Remember we called that thingy, I don't know, the graph, yeah? That thingy, yeah? Look, this graph, yeah? Y equals x squared, yeah? Is this graph, right? Yeah? When x is 0, y is 0. When x 1, y is 1. When x is 2, 4, right? 3, 9, yeah? Okay? So if fx is x squared, and then we pick a value, like if it's 1.5. 1.5. So let's pick the k equals 3. What are the 3 closest neighbors to 1.5? If we have a training data on integers, yeah, 1, 2, could be 0 or 3, right? It doesn't matter, we pick 1 or 3. Okay? Yeah? Alright? And then what's the prediction? So we know these 3 are the 3 nearest neighbors. So look, what is y? This is 1, right? f1 equals 1, f2 equals 4, right? f3 equals what? 3 squared equals what?
9.
9. Okay, so what's the average of this one? 1 plus 4 plus 9 divided by 3 equals
About 5.
14 divided by, sorry?
Is about 5.
Is it about 5? 3, 4. So we pick the 3 nearest neighbor could be 1, 2, 3. Okay, but this is the difference, the error rate. You know, if this is the produce too much error, right? Because it's equals to 5. But look, it's not 5, right? If you pick this, what happens? If you pick this neighbor, right? If you pick 1, 2, 3, you get a 5. If you pick 0, 1, 2, right? I put a 0 here. So what's the average? 1 plus 3, 1 plus 4 plus 0 divided by 3. Yeah? 5 divided by 3. Roughly 1.7, right? Yeah? So you see, by picking, but the correct answer, the correct prediction is 1.5 squared will be 2.25, okay? So which one is closer? Which one is closer? 1.7, right? 1.7 instead of 5, right? Yeah, this one is closer. So you see, they produce the large difference depending on how you pick the neighbors. Yeah, yeah. If we increase the k, the accuracy might improve. Make sense?
Yeah.
Or if we have more data points around, let's say if we have more data points around the 1.5, right? If I have one more data point around 1, and then the accuracy will be very close to 2.25. It depends on how these data. So you see what can you tell me what's the advantage and disadvantage of KNN? Okay, based on this, the advantage and disadvantage. Advantage. Simple. Yeah, we just pick the k nearest neighbors and make an average. Am I right?
Yeah.
What's the disadvantage? The accuracy depends on how you pick, where are the neighbors, right? Yeah, you could produce a very large difference, right? You see, yeah. And if there are 1,000, a million data points, it could be very slow to evaluate the distance, right? The shortest distance. If there are quite a lot of data points, right? If there are n data points, the time complexity will be O(n), right? Right? Because you need to go through this n to calculate the distance. And also, okay, you need to sort it, right? You need to find the distance, find the shortest distance. So if you sort it, it will be O(n) log n, right? But if we're using the heap, remember the heap, the binary tree, right? Yeah, max heap, min heap. If it's max heap, this is the biggest, always biggest. If the min heap, this is the smallest in the binary tree, and then you'll be reduced. The time complexity will be OK log n, right? This is a bit better than O(n) log n, right? Because k is smaller than n, right? Much smaller than n, so it will be OK log n, right? Huh? Make sense? Okay, so let's write the structure of O(n), okay? And you tell me, okay? Define k and n. Okay, our input is x, yeah? And then n equals, let's say equals 3, okay? By default, yeah, we can put a default value. Can we put a default value? If we don't pass the default value, it will be, if you don't pass the n, it will be 3, yeah? So we need to assert, first of all, we need to assert n bigger, let's say bigger or equals 3, okay? Okay? Now we have a data point. Let's say the data is here, okay? It's existing here, okay? But we put it here, data is here. And let's fill the data. For example, let's fill the value of fx equals x squared, okay? Let's say this complex model is fx, yeah? But this data could be already known, so we just need to for I in range. Let's just fill the data, yeah. But we can move this outside, okay? Let's move this outside, for example. Maybe we'll put a data here. Data here, okay? Data here, n equals 3. Okay. So for example, this data, what does it look like? It's a dictionary, and for I in range, let's say to minus 100 to 100 minus 1, 101, and then what? Data I equals I times I, right? I times I squared. Okay, so then we fill the data, yeah? We fill the data. The data is the keys. Okay, so let's we already have this data. Data is the keys. Data is like key value pairs, right? For example, 1, 1, 2, 4, 3, 9, something like that. Depending on your data, it could be complex. Yeah? This is the given given already historical data. Yeah? Historical data. We already know training set. Yeah, training set. Okay, training set. And now we want to find calculate distance to all the data points in the training set. Okay, so now let's say we want to get a cost. Cost equals what? Cost is an array, right? Let's say I and then A, B as the distance. Yeah, we can calculate distance, right? I to the distance, I minus x, this is the distance, right? And that's the tuple, yeah? The first value is the neighbor, and the second value of the tuple is the distance. It's the cost, the distance to x, right? We use the absolute value. Then what? For I in data, right? For I in data. Okay. And then we now need to sort it, yeah? Let's use the normal sort, okay? Cost dot sort, right? But we want to sort by what? Key, right? Equals lambda x1, right? Okay. So we want to sort the cost array by the distance in ascending order. That's what it means. Lambda x1, because x is the tuple, right? x0 is the neighbor. x1 is the cost, is the distance. Yeah? Why we need to sort the distance? We want to find out the shortest k neighbors. Am I right? Are you with me? Yeah? Are you with me? What's the time complexity of this one? If there are n, if the length of the data is n, what's the time complexity if we sort an array with n numbers? What's the time complexity if we sort the numbers with log n, yeah. So if we're using the heap, the time complexity could be improved as OK log n, right? Yeah? Okay. The heap, yeah, because we need to, every time we maintain a heap, we insert the number into a heap, it needs the O log n, right? And how many times we need to take, to take a number, max number or shortest number, smallest number from a heap. Okay, so this heap, yeah. Every time we take this is smallest heap, I will take it out one time, but we need to rebuild a heap. That's log n. And how many times we need to take it? Do this k times, right? Because we need to compute the k nearest, right? Yeah? So it needs OK log n. Which is better? O n log n or OK log n? Which is better?
Okay.
Why is that?
Because
K is
smaller.
than n, right?
Yeah.
N could be a large, a million, if there are a million data points, right? This is obviously this is much better because k could be 3, right? 3 compared to a million, right? I do it 3 times, I do it a million times, which is faster?
3 times.
Obviously, yeah, good job. Okay, now we sort it. We sort this array, and then we need to find out the smallest one, okay? Then we can return now. Return what? The distance. We want to sum it first. Sum what? Sum data, yeah, the data what? X what? X 0, yeah, because 0 is the neighbor, right? For x in, okay, so data, now now the cost, yeah, the cost is already sorted. So cost up to k, up to n, right? Up to n is the shortest distance, cost n, right? So in cost up to n, right? Up to n. Yeah, because cost is already sorted, right? Sorted. The first element is the neighbor, so we take in the neighbors. The second one is the distance to the input. Right? This is the sum, and how do we calculate the average? How do we calculate the average? We have sum. We have how many numbers? What's the sum? How many numbers? How many elements are there in here? How many numbers? How many elements?
N.
N, yeah. So we just need to divide by n, right? This is sum, yeah. Sum divided by n is the average, yeah. Average, yeah. This average. We want to, yeah. Do you get it? So overall, this is the simplest KNN demonstration, yeah. So we use the average here, but sometimes we could use the weighted average, right? Or we could use the median, or we could use some other functions. Yeah, this could be changed, right? This could be adapted to different needs. And the sorting, as I said, could be improved to OK log n based on the heap, right? And then this input, yeah, input could be different. Something will be quite a complex, complex. Could be a vector, right? Instead of singular. Look, this x is the value. Then how about it could be a few values, right? It could be a vector, and then you need to compute the distance functions. So the distance function may not be so obvious. In this case, it's quite obvious, yeah, because we're given a number f2, right? 3. What's the distance between 3 and 2? Easy, 3 minus 2 distance, right? Absolute value, right? Yeah. But it could be very complex distance functions, like it could be something, it could be a few 100 values, and what could be distance between those, right? Yeah, or maybe two values x, y, then you can calculate the distance. Yeah. Look, if it's 2 elements, we could calculate the Manhattan distance, which we talk about, right? Is what? Absolute value of data x, data. Yeah, data. What's data? It's the difference between 2x value plus absolute value of data y. Okay? Yeah? Or you could use this as a square root function, yeah? Square root data x square plus data y square. Yeah? That's the two values if the input contains 2 values. And how about 3 values, 4 values, 5 values? You could define different distance functions, right? For the input, right? Okay, and data, we talk about data. Data could be very huge. So if it's very huge, then the performance of this KNN could be very slow. Because at real time, you need to evaluate the cost of the input to the existing data in the training set. It could be slow, right? And if we reduce the data set, what could happen? The accuracy might degrade a lot, right? Yeah, it depends on how you choose the data. Generally, the more data, the better, the higher accuracy. Am I right? Yeah. But as I said, the more data, the slower. And if we reduce the number of the training data, we also degrade the performance, right? If only there are only a few data sets, then the prediction will be quite highly biased, right? Because it could be picking some extra some incorrect data points from the data set and produce totally incorrect prediction, right? And n equals 3 is usually k, and k could be 5, 7, 9, those odd number, which is better, right? Because we don't want to avoid, we don't want to. So why n needs to be odd? Because we don't want the even votes, right? As I said in the beginning, triangle, square. If we have if n equals 4, what could happen? 2 votes belongs to triangle, 2 votes belong to square, and then we can make a choice, right? But if it's k equals 3, then we always can make a choice, right? Because there's a majority, right? There's a majority. Okay, so that's the KN, that's the machine learning. That's the very simplest machine learning algorithm model, okay? Any questions so far?
No.
Is it interesting? Useful? Yeah? Useful, yeah? You see? Only 1 line, 2 line, 3 line. 3 lines implement of KNN machine learning algorithm, okay? You see how powerful is that? Got it? Yeah? Okay, you want to say bye-bye to people?
Bye.
Bye-bye. More upbeat, please. Can you be more upbeat, please?
Meow.
More?